Hi everyone, I did my final project on a architecture called NoProp, which stands for no propagation, with the question of, does model training without full back propagation improve catastrophic forgetting? So the intro to that, gradient descent, we all know well, it can be computationally expensive. The NoProp algorithm offers a solution to that via an application of diffusion models, which is to say we're training noise labels on input data in localized discrete blocks and only backpropagating on those discrete blocks, vice backpropagating across the entire network. And so to go a little bit more into that architecture, we have this noise schedule in each of these T blocks. We implement that noise schedule, the CNN that we run our image through. We utilize the MNIST dataset for this. So we run one of those digits through our convolutional neural network, combine it with a noised version of the labels, and then send that combination input to a multi-layer perceptron, and then train that and backpropagate the weights through, and then eventually get our prediction out of that. And so this is just a walkthrough of that algorithm in a more qualitative kind of way to kind of see what's happening there. So our results that we got for it were okay, but not great. We got a test accuracy of 0.94 with the train accuracy of 0.97, roughly 0.98, which is good for a lot of classification problems, but obviously for MNIST, it's worse than the paper's claim for the architecture, and B, worse than most modern algorithms on MNIST. And here's an image version of what we got. You can see we got an error rate of 1 out of 15. Then you can also see in our investigation of catastrophic forgetting, our results were similarly not great. We sequentially trained the network on 0, 1, 2, 3, 4, 5, etc., with the final test accuracy of about 1 out of 5, indicating really the only last trained class was the one that was being properly classified, and that's further exemplified here. We conducted some additional investigation to see if increasing the class size, the subset size, would improve results, and it did not. But regardless of that, the fact that we were able to get the 0.94% or 94% test accuracy, that's non-trivial, and I think signals some real value to explore via the application of this architecture to classification problems. So thank you very much. Happy to answer any questions. Take care. Bye.